Hello, I hope you all had a good weekend. We're going to be covering 6-5 today. If you can believe it, we've only got 3 more lessons of pre-calculus. 6-5 today. We're going to do 6-6 has 2 parts. We'll do one tomorrow and one on Wednesday, and then you'll have a review day, and we're going to be done with pre-calculus. I'm glad you stuck it out to the end, and I'm going to be sorry to not see you anymore, even though I don't get to see you right now. At least I get to see your work. So feel free to stop by and to any of the noontime discussions this week so I can see your faces and give a little chat. But anyways, on to our math. So 6-5, limits of functions at infinity. We're going to talk about one-sided limits. Example 1, the limits of a polynomial function. Actually, this is the worksheet. Hold on, this is the homework paper. Let me find the notes. There we go. Limits at infinity and two-sided limits. So the limit of a power function at infinity. So if we're looking at a power function and we're talking about what happens at infinity, if you can remember, if your exponent is even, both ends have the same behavior. Okay, they're either both up if it's negative or positive. So if we have positive x to any even power, the both ends go up. If we have negative x to any even power, the both ends go down. So we can think about if we're going to positive infinity, what's going to happen? If we're going to negative infinity, what's happening? Okay, and then for any odd function, we have opposite ends. If you remember back to algebra 2, odd is opposite, so the ends are going opposite. This is positive, so it's going up. If we had a negative function, odd opposite, it would be going down over here. So this is going to be, I think, a visual lesson for this part. So I usually just draw a quick picture and see what's happening. So it tells you for a limit of a polynomial function, when you're finding the limit of the function, you basically find the limit of the highest degree. So we're going to look at this and we're going to say which degree is highest. It's here. So we're going to do the limit. The limit as x approaches negative infinity of just the x to the third. And if we do that and we think of a sketch of x to the third and it's positive, we're going like this. And we're approaching negative infinity. So negative infinity is to the left. What's the graph doing? It's going down. So the answer is going to be negative infinity. Okay. So then this one, the highest degree is here. Make sure you include the sign. So we want the limit as x approaches positive infinity for negative x squared. So if I'm going to draw this, negative x squared, squared is even. So it's going to go the same direction. Negative goes down. So we have a graph that's going down. Okay, if we look towards positive infinity, which is over here, the graph is facing downward, which means it's going to equal negative infinity. Sorry, that was a bad sign. Okay, so we're looking only at the highest degree. We're looking at whether the end behaviors are the same or opposite and which direction they're going. And then you're going to look at which direction you're approaching from. So this one is, the highest degree is here. So we're doing the limit as x approaches negative infinity of 5x to the fourth. So if we draw a quick sketch, it's even. So same direction, positive. So they're both going up. Again, you don't have to sketch this neatly. You can also put this in Desmos if you want and see what the graph actually looks like, but a rough sketch to get the idea is fine. So now we want to go towards negative infinity, so towards the left. If we go towards the left, the arrow is pointing up, so it's going to equal positive infinity. So you're going to see this on your worksheet, a few more examples, so make sure you do that carefully. Draw a quick sketch if you want, or use Desmos to draw an accurate sketch. Think about what direction that problem's asking you about. Go in that direction and say which way do the arrows point. They're either going to point up or down. Up is positive, down is negative. Okay, so what happens if we get a reciprocal function? The reciprocal function is when we have 1 over x, the 1 on the top and then some x to any power on the bottom. Anytime you have a reciprocal function, the limit is going, as it goes positive and negative infinity, is always going to equal 0. Okay, so that's the rule. So if we look at this one here, it doesn't matter what the degree is. As x goes in either direction, and we have a 1 on the top, x to any power on the bottom, the answer is going to be 0. So that's just 0. The next one's much more complicated because we don't have it. It's not in the right form right now. We can't factor this. So what we're going to do is we're going to make these into reciprocal functions. To do that, we're going to take every term and divide by the highest degree. So the highest degree on this whole thing is x to the third. So we're going to take every term and divide by x to the third. And then we have minus 3x squared divided by x to the third, and then plus 1 divided by x to the third. And then we're going to do the bottom, 2x to the third divided by x to the third, plus 4x divided by x to the third. And then we're going to simplify and break these apart. So if I look at the first one, x to the third over x to the third is just 7, minus, we're going to take the whole numbers away. So we put 3 times, and we're going to simplify this. If we simplify that, we're going to end up with a 1 on top and an x on the bottom. And then this one here is just a whole number anyway, so we're going to just leave that as it is. And on the bottom, we're going to divide this, and it's going to just become 2, and then plus, and then we're going to simplify this. The 4 goes in front, and then if we simplify this, we get 1 over x squared. So what we're doing is basically taking each of our fractions and breaking them apart so that we can get the 1 over that we just discussed, because we know the values of those numbers. So we're trying to make a number value. If we can make these all into reciprocal functions, then we can solve. So every one of these functions, no matter what the degree is on the bottom, if it's a 1 on the top, becomes 0. So we have 7 minus 3 times 0 plus 0 over 2 plus 4 times 0. So this gives me 7 minus 0 plus 0 over 2 plus 0, and which gives me 7 over 2, or 3.5. You can graph, again, anything you want to check and see what it looks like, and you'll see that it's approaching that value. But to do these problems, again, find the highest degree anywhere, divide every term by that, just by the degree, the x part of it, don't worry about the number, and then split it apart. Simplify, make sure you take numbers out and leave just those fractions with a 1 on top, and then you'll be able to replace those with zeros. So do that process really carefully, and you'll be able to solve those. And the last part of this lesson is if we have a limit that's evaluated as it approaches from the left and the right, so one-sided limits going from one side to the other, the best way to do this is by graphing. And so we're going to look at this example, and I graphed this on Desmos already, so you can do the same thing. So it has to be for the limit as we approach 2. When it doesn't have a direction, we're coming from both directions. And this one says as x approaches 2 from the negative side, and this one is x approaches 2 from the positive. So let's look first. I like to do these ones first because this one's more complicated. So as we go from the left, from negative direction, as we come from the negative direction towards 2, the graph is going towards, and this is going to continue along because there's an asymptote, if you can tell that, at 2. So it's going to continue along, right along 2, all the way towards negative infinity. And as we come from the right, as from the positive direction, it continues and goes along all the way towards positive infinity. When you go from different directions and they have different answers, if you remember now, this is D and E. So as we approach from one direction to the other, the answers are different, then it does not exist. If you were to factor this, you'd get x plus 3 over x plus 3 times x minus 2. These would cancel. You get 1 over x minus 2. And if you plug the 2 in, you'd see you get 1 over 0, which is undefined. So that's why we see that this does not exist. Okay, so when you're doing these problems, any problem that you got this where you're approaching from different directions, do it by graphing. So go to Desmos.com, plug in the equation, just like I did here, okay, and then look at the graph and check from either direction.